Hi, everyone. This is Heather Kraus, and welcome to the first Data Amnesty Salon of 2020. This is being recorded live on January 14th, and then we will post it on our YouTube channel after for everyone who doesn't get a chance to join us live. And there's just a couple more people joining us by phone, so I'm going to just ease into getting us started. We have a number of people online and a number of people on the phone. I know that we have Vienna being represented, and also Washington, D.C. in the United States, Toronto in Canada, and the Bay Area in California in the United States, and the West Coast, somebody from Vancouver in Canada. And we are delighted to have you all. Oh, and Paul from New Zealand, welcome. It's very big time difference there. Yeah, so we're very happy to have you join what is the first of an ongoing series of Data Amnesty Salons for the year 2020. We've run Data Amnesty Salons in person at quite a number of workshops and online a few times in 2018 and 2019. And we've gotten so many requests that we're going to make it a regular feature of the We All Count online set of products and services and tools for you to use online. For those of you who are new to We All Count, you can check us out at weallcount.com. We All Count is a project focused on equity in data science, and our motto is to demystify, democratize, and demonstrate when it comes to data. So our mission, you can read the full our full reason for being on our website, but essentially we're here to help data be accessible to anybody who wants to learn about data, anybody who wants to use data, and to kind of take away the mystery and the exclusiveness around data science that can cause a lot of inequities. And so one of the things that we found in the past couple of years is that there are a lot of people who need to make decisions with data or even do analysis with data that got into their positions of power before the quote data revolution. And they weren't educated about data in the same way that a lot of younger people who went through a different type of more data-oriented educational system are. And sometimes these people are even CEOs or making decisions for countries or cities or big companies, and they don't really feel comfortable saying to subordinates always, can you please remind me this thing about data? They feel embarrassed to ask the questions. And the same thing with a lot of potentially marginalized groups or underrepresented groups in data often feel like they have to present like they know more or know things that they weren't ever given the opportunity to learn in order to maintain their status in a world where data is kind of a rock star thing. So in order to counteract that, we are offering the Data Amnesty Salons, and where anybody can ask any question anonymously or not anonymously, totally up to you. And the idea of data amnesty came from my childhood, where I spent many, many days at my public local library, which I loved. And I checked out a lot of books, and I had a lot of overdue books always. And my public library had something called Library Amnesty Day, where you could bring back any book, whether it was damaged, whether it was like 2 years overdue, whether a page was missing from it. You could bring back any book, no questions asked, and no fines accumulated. Like all the fines were forgiven. And the library did that because they wanted their books back more than they wanted the fines. And they wanted people in the libraries more than they wanted people staying away from the library because they owed this big fine or they had ripped a book or spilled coffee on a book. And that's how we feel about data. We would much rather have people understand data, work with data, feel comfortable around data than we would like to be seen as some kind of fancy rock star that has all this mystical knowledge. So that's what data amnesty salons are, and we've conducted them at large national governments and cities and conferences around the world. And now we're conducting them online. And there's three ways, I'll repeat this at the end, but there's three ways that you can get questions into us. You can tweet them to me. That, of course, is not anonymous because that's on Twitter. But we also do have a link to an online survey that is totally anonymous, and lots of people are using that to submit questions. And then the third way is you can email them to me, and all of that information is available online and also at the end of this recording. And also it'll be down in the comments in the YouTube videos. So now that you understand what data amnesty is and why WeAllCount is bothering to do it, we'll get started and jump into some of the questions. Just to set everybody up on the same foundation, here at WeAllCount, we use a 7-step framework for the data lifecycle. And you can download this also on the website. Funding, motivation, project design, data collection, sourcing, analysis, interpretation, and communication are kind of the 7 steps that any data product goes through. And we find that breaking them down into steps allows people to not feel as overwhelmed and to be able to think through kind of what their next step is or identify where they are in their product, in their data work. So the first question that we got, we're actually going to answer 2 questions in one. What actually is data? This question came from a journalist, and it is an interesting issue. I actually was able to speak with this person and who asked this question. And one of the things that they found is when they're having conversations about kind of database journalism or using data to write a journalism story, it seems to be very confusing to them because some people think that data is like the responses to a survey. And some people think data is kind of the findings of a journal article or a piece of research, and lots of other things in between. So how do we talk about that? What do we mean when we have a conversation that says, you know, where did you get the data in your data journalism story, or where did you get the data for your research report? And accompanying that question, this one came through the anonymous survey, so I don't have any background on who is asking this, but what is the real difference between qualitative data and quantitative data? So you'll hear that a lot in people talking about data. They'll say, oh, you know, I'm very comfortable working with quantitative data, but I don't know that much about qualitative data. What does that even mean? So we're going to look at these 2 questions together in a series of slides. So this is a great example of what data can look like in the wild. This is a project that I'm working on in rural Bangladesh. And these are 2 women that live there, and they are part of a group that is collecting data about the different ways to get more milk from their dairy cows. So this is them collecting data on what they feed their cows, what kind of vitamins they're giving their cows. And you can see that this data is largely in pictures. So they're putting stickers on the grid when certain things happen. So that is what we would call microdata. So microdata is the actual kind of smallest, most granular type of data that is being collected. So for the women who are collecting data about their cows and the food that they eat and the vitamins that they get and things like that, and then how much milk they produce, the microdata is for one cow, what were all those stickers? So for one cow, what did that cow eat that day? What vitamins did that cow have that day? And how much milk did that cow give that day? So that's microdata from that example. In this example, this is what you're looking at on the screen now is actually an example of a administrative survey that a national statistics body like Statistics Canada or the Census Bureau of the US or Eurostat, they collect national data, and you can see that each person in this data set has one row. So there's an ID number and a state, and a self-identified race, and a self-identified gender, and a self-reported annual income amount. So each person is one row. This is called microdata. So this data has not been very processed, and it's very hard to kind of get knowledge or information from microdata. People generally take microdata and they aggregate it. So using the administrative data that we were just looking at, you can see that we can aggregate that data into different groups. So we can look at groups of race, groups of gender, and then average what their incomes are. So aggregate data takes the microdata that you have and groups it and then processes it in some way. In this example, we've taken an average income. So for the journalist that asked the first question, aggregate data is what journalists are often using. Journalists are not often using microdata, not never, but to get microdata into something called aggregate data takes a fair amount of sophistication. You need to aggregate it in ways that will preserve the knowledge and the information without accidentally introducing too much error. So that's aggregate data. And then microdata and aggregate data are usually combined together to create statistical information. And so this is sometimes what everyone will also call data, is statistical information. So if I build a model with the data that we're looking at about income, race, and gender, I can build a model that predicts how much a person's income will be based on the combination of their race and gender. And I can build that model using the microdata, and then I'll get different kinds of information. Like I can say, I use my statistical model to find out that men in this sample are earning about $20,000 more than women. So that's statistical information. It's not actually aggregated data because it isn't just taking the data and summing it up and building a model, which is introducing a certain amount of probability. And that's statistical information. So that's often used a lot by journalists as well, and often called data as well. And then often this statistical information is put into words and put into a research report or an article in a journal or a piece in a newspaper or an online website. For example, men in this state tend to earn 84% more than women on average, plus or minus 2%, which is a very important part of the statistical information. Because like I said, statistical information isn't just aggregating, you're introducing some probability and some uncertainty. So this is often called data as well. I would say when I do a lot of work with journalists, which I really, really love. And when I'm talking to most journalists or editors and they say, we want to include some data in this news story, usually what they're talking about is this. So statistical information that's been included and that can be part of the narrative. So men in this state tend to earn 84% more than women is a form of data. And if you want to make sure that you're on the same page as the person you're talking to, it's a good idea to spend some time getting clear on what exactly you mean by data. Do you mean microdata, aggregate data, or statistical information? Oh, so I'm going to back up a couple of slides to talk about what's the difference between qualitative data and quantitative data. So now that we've kind of talked about what data actually is, we want to talk about what is the difference between qualitative data and quantitative data. So of course, this is a huge question, and it's one of the things about running a Data Amnesty Salon is that we need to find ways to talk to each other about pretty complicated and nuanced things in ways that are acceptable and don't turn into some kind of 4-hour PhD lecture. Not that those are bad, 4-hour PhD lectures are great, but that's not the point of this particular event, this particular salon. So essentially, the traditional definition of quantitative data is data that can be counted. So for example, in this case, the average income is quantitative data because that's something you can actually count. It's physical, it exists in physical form, and you can actually count up. In the olden days, if you were paid in dollars, you could actually count the dollars. In more modern times, you can get a quantifiable physical count of the number of dollars in your bank account that were deposited by your employer or by your job, and that's your average income. So quantitative data is something that you can measure with numbers or count. Other examples of quantitative data, in addition to income, are things like your height, because you can measure that with a ruler and kind of count it up in numbers. So height is a good example because the units of measurement can change. You can measure in centimeters, you can measure in feet, you can measure in meters, you can measure in all kinds of other systems of linear measurement. But those are all ways to count. Qualitative data traditionally is used to define data that can't actually be counted and is more of a traditionally defined as a softer form of data and oriented more towards narrative and concepts. So qualitative data tends to be more conceptual. So for example, race is technically a qualitative variable. You can't count whether somebody is an American Indian, Asian, Black, or white. That isn't something that you can measure with a ruler. It's not something that you can count in dollars and cents. It is a concept that is softer in nature than something that you can, hold in your hand and count. So technically, that's a qualitative variable. Now, if somebody says they're a qualitative researcher, it's likely that they use different research methods. There's tons of very good books on qualitative research that you can find out there. But essentially, that person is going to not count things and then aggregate them and sum them up and put them through models as much as they're going to spend time talking to people, observing people, conducting focus groups, conducting ethnographic research. Things like that are usually considered qualitative methods, whereas quantitative methods are more like, measuring how many clicks a website gets or measuring the height of children as they're growing up. Those are qualitative research. However, this has really become blurred in modern data times because we now have huge amounts of computing power, which allows us to do things with data that would have traditionally been considered qualitative data and turn it into what would traditionally be considered quantitative data. So for example, if we think about sentiment analysis, so things like comments on a website. So some of my clients run consumer-facing websites, and they get comments from those consumers. If they're launching a new makeup product, they'll wait and see what the reviews are, what the comments are. So that's qualitative data, right? People writing out paragraphs and sentences of reviews of a newly launched makeup product. It's qualitative data. Somebody attending a local city hall meeting and then filling out a comment form afterwards is qualitative data. However, we now have this new stuff where we can feed all that qualitative data, all that text into a bunch of algorithms. Some of them are called natural learning processing or NLP. But you don't need to understand that. You just need to know that that qualitative data, those texts, those comments are getting fed into computer algorithms that are then turning them into numbers. So they're turning them into numbers of kind of satisfaction on a scale of 1 to 5. How satisfied were people? They're counting up things. How many times did people reference this or that? And how intensely were the people talking? So there's intensification ratings. So if somebody said something that kind of seemed positive about your new makeup line, did it seem intensely positive, or was it just kind of mildly positive? So this is the same way that this is a way that qualitative data is kind of slowly turning quantitative. And it's the same thing with this example here, where we're looking at, say, race and gender. Race and gender are technically qualitative things. They are self-identified, they are fluid to a certain extent, and they aren't binary. However, in statistical analysis, because so many people in this day and age want to run their data through statistical analysis, we turn things like race and gender into quantitative data. So in this case, with American Indian, Asian, Black, and white, we might assign those a number, 1, 2, 3, and 4 in any order, and then put that into a statistical model. So that's technically a way of putting kind of qualitative data into a quantitative model. So we need to be very careful about not being too, when we talk about qualitative data and quantitative data, being careful that there are a lot of nuances these days, that it's not just focus groups and surveys, how it was in the old days. So that is the beginning of the answer to qualitative and quantitative data. And we have a comment. Great, thank you. We're so happy to get live comments. My screen temporarily froze. Did you say gender was qualitative or quantitative? Thank you for your question. Whoops, which I accidentally made really big. I said that gender was qualitative because it can't be counted and it's self-identified and it isn't binary. However, that's probably technically an opinion, as everything is in statistics. So that is what I said. Excellent. There we go. So we're going to leave that question there for now, and we are going to go on to a major question that, here we go, that came up at the last conference I did of 2019, which was the American Evaluation Conference in Minneapolis. And we did a few data amnesty sessions there. And at one of them, somebody wanted to talk about bootstrapping and why anybody would use it. And this is also one of the kind of risks of running data amnesty, is that why a lot of data scientists and statisticians don't want to run data amnesty sessions is because there's this feeling that you have to know the answer to everything. But my kind of mission in life is to democratize, demystify, and demonstrate. So I am quite comfortable saying I do not know everything about statistics and cannot answer everything on the spot. But what I am happy to commit to is taking your questions and finding people who can answer them. So that is what we have done with bootstrapping. I was vaguely familiar with what bootstrapping was, but I certainly didn't want to give more than a very high level summary of what I thought bootstrapping was. And I promised that I would get back to you after talking to several experts about what bootstrapping is and why would anyone actually use it. So here we go. Okay. In order to talk about what bootstrapping is, we need to talk about two things that kind of go into making up bootstrapping and why anyone would use it. We need to talk about a sample and a confidence interval. Because what bootstrapping basically does is take your sample and build you a nice confidence interval. If you don't understand what that means yet, don't worry, because we're going to talk about what is a sample and what is a confidence interval. Okay, what is a sample? Here is the community of people that you are interested in talking about. So let's just say this is our city, our community, and we would like to be able to say what they think about a particular issue. Most often, you don't have the time or the money or the capacity to ask every single one of these people in your community what their opinion is. Sometimes you have the time and money, but not the capacity. Sometimes you have the capacity, but not the time. There's many combinations, but usually it's very hard to get an effective population-wide survey of people. So instead, you're going to take a survey. Instead of talking to every person, you're going to take a survey. And you're going to take a survey from a smaller group of people than your entire population. And the smaller group of people, like a little subsection of your population, that's called your sample. So here's my population. Here's my whole population, all of these people. And then this yellow line here shows this is my sample. Community sample. What you want is to understand the feelings of your community, not your sample. But you can't afford to ask every single person in your community what they think and feel. So instead, you ask the people in your sample what they think and feel, and then you take the data that you've collected from your sample, and you do a couple of things to it to make it represent the thoughts and feelings of your community. So how you collect your sample determines the different kind of statistical things that you need to do to your sample to be able to talk confidently, accurately about your community. Today we're not going to go into all the different ways to collect a sample. We will on another day. But today we're just going to say if you've done something that's very fancy, the scientific term random sampling, which means that everybody in your population essentially got their names thrown into a hat, and the number of people that you sampled were drawn randomly out of the hat. You shook up the hat and everybody had the very same probability of getting their name pulled out of the hat as everybody else. If you've done that, then you can basically assume that the feelings of your sample will be pretty much representative of the feelings of your community. This is a big issue and there's a lot of nuance. And we'll talk about it at greater length at another time. And if you're actually going to be drawing a sample, we should do some more reading, and I can give you lots of recommendations of videos to watch and what to read. But essentially, for the purpose of understanding what bootstrapping is, you just need to know that a sample is a small subset of your community who provided you with answers to your survey or answers to your research. Okay. Second part of understanding Bootstrap is what is a confidence interval. A confidence interval, the definition is it's a range of values that we are fairly sure contains our true value. So let's pretend from the survey, the picture above, that we asked a sample of people what their sense of belonging was on a scale of 1 to 5. What is their sense of belonging? So 1, if they give us a 1, that means that they're not feeling very connected to their community. And if they're giving us a 5, that means that they have a very strong sense of belonging. Let's pretend that our sample, on average, when we averaged it all together, so we're taking the microdata and we're aggregating into an average. Let's pretend that they said it was a 4.1. So on a scale of 1 to 5, our sample said 4.1. So the question that our confidence interval is trying to ask is, how confident are we in that number being representative of the actual community? So we know this 4.1 is the sense of belonging for our sample. We want to know whether we're very, very unconfident that 4.1 represents the population, or we're very confident that the 4.1, I'm going to write this too over here. I'm not. Okay, so that 4.1 is from the sample. And what we want to do is talk about the community. So how confident are we that this 4.1 from the sample represents the true feelings and experiences of our entire community? Are we very unconfident? We think it doesn't represent it at all. Or are we very confident? We think, yes, we're very sure that that 4.1 represents the actual feelings of the community. So the confidence interval is one of the ways that researchers and statisticians try and say, this is how confident we are. And usually what you hear is we're 95% confident, right? We're 95% confident, or we're 90% confident that that this range of answers is true. So a confidence interval is a range. So for example, a 95% confidence interval might be that we are 95% sure that, based on the sample of 4.1, we are 95% sure that the community has a sense of belonging rating between, say, 3.5 and 4.6. And this right here is our confidence interval. So this is us saying we are confident that the community's sense of belonging is somewhere between 3.5 and 4.6. And what we're not going to go into right now is the technical, traditional way of calculating that confidence interval. All you need to know is that there's a formula that's used for calculating that confidence interval. And that formula is based on a couple of things. The number of observations in your sample. So that's how many people from your population answered your survey. If it was, if your population is 100 people and 15 answered your survey, then your sample size is 15. So that makes a difference in how big or small your sample size is. The mean, so that would be the 4.1. So the kind of the outcome of your sample. So the outcome of our sample was that on average, the average sense of belonging was 4.1. And then the standard deviation of your population. So do not be alarmed by this word. This word, standard deviation, just means basically how close together the people are in their feelings of sense of belonging. So in other words, if you're living in a community where most people have basically the same kind of feelings about their sense of belonging, most people are a lot like each other in your community. That means your community will have a small standard deviation. Deviation is a fancy word for like distance or difference. So how different are the people in your community around this question, around the question that you care about? So if your community, most people feel basically the same, about their sense of belonging, your standard deviation is very small. People are a lot like each other. However, if your community is really different, and some people feel like they really belong to a community, some people really feel like they don't belong to a community, and some people in the middle, they kind of feel like they belong to a community, then your standard deviation is going to be really big because people are really different in your community. So this is really important in trying to figure out the confidence interval. Because how similar or different people are in your population make a big difference in how good of a job your sample is going to do in telling you anything about your community. But here comes the rub, okay? It is the standard deviation of your population. So the fancy formula in math for calculating your confidence interval is based on the standard deviation of your population. So we need to know how similar or different people in our community are in their feelings of sense of belonging. Now, of course, if you think about this for very long, it's going to become obvious to you that this is a problem, because the whole point of this research is that we don't know what my community thinks and feels about their sense of belonging. We don't have that data from everybody in our community. If we had that data from everybody in our community, then we would not be taking a sample and asking them this question, right? So what mathematicians do is they make an assumption about what they think the standard deviation of our population is. They put that into the big fancy math formula and they get a confidence interval. So that's how kind of traditional confidence intervals are created. And this right here is what makes some people uncomfortable, because it's based on a very big assumption about whether the people in your community are a lot like each other or not a lot like each other, without usually really knowing that. I mean, there's some situations where you do know that, but there's a lot of situations where you don't. So this guy named Brad Efron in the 1970s figured out a way to create a confidence interval that doesn't rely on that assumption, the assumption of how similar or different the people are in your population. This new way is called bootstrapping. And bootstrapping is a new way to get a confidence interval without making a lot of assumptions about your population, whether it's similar to each other or different, and how those similarities and differences are distributed. Again, this could be a 4-hour PhD lecture, but this is a summary to get you understanding what the word means, bootstrapping. So essentially, let's pretend that these are the 8 people in our sample that we asked for their sense of belonging. So this is our sample. And each of these people got to give a answer on a scale of 1 to 5. This person said 1, this person said 5, this person said 2, this person said 3, this person said 4, this person said 5, this person said 1, and this person said 3. So this is our sample. And so what we're going to do is take an average of that. So 1 plus 5 plus 2 plus 3 plus 4 plus 5 plus 1 plus 3 equals 24 divided by 8. Okay, so the average in this sample, the average sense of belonging is 3. And so we have our sample size, 8 people. We have our result from our sample, that's 3 right here. And what we want to know is how confident are we? Is that 3 almost certainly a close approximation to what our community thinks? Or is this maybe really far away from what our community thinks, or maybe we have no idea? So one of the things that Brad Efron, who developed bootstrap sampling, says we can do is, instead of making a big assumption about a population, what we could do in theory is to take a whole bunch of new samples from our population. So this is called resampling. which because it's doing something again, you're sampling again. So in addition to our first 8 people, we would take a second 8 people, and then we take a third 8 people. And in fact, we would keep doing this over and over in our population. We would keep getting new samples, keep drawing new names out of the hat until we have maybe 100 different samples. And each of these, of course, would give us a different average. We already know that this average is 3. Let's just pretend that when we add these people up and take an average, it's 4. And when we throw these people all back into the hat and choose 8 new people, say now we get 2.8. We could keep doing this until we had hundreds, if not thousands, of unique samples. And then we could take all of these results and line them up and figure out what the 95% confidence interval is. So how we would do that, let's see if this is white. Yes, this is not white. Okay. How we would do that is each of these samples, so this 3, this 4, this 2, we put in order. We'd make a histogram like this. And we would do the 5 levels of belonging right here. 1, 2, 3, 4, 5. And every time we got a 3, we would put it in. That's 3. And then we got a 4. We'd put that in as 1. Oh yeah, sorry, no, that's wrong. Sorry, ignore my thing. Okay. 1 unit said 3 because this sample up here said 3. And then 1 unit says 4 because this unit right here, this sample here says 4. 1 unit says 2.8 because this unit here, this sample here has 2.8. So you do this over and over again until eventually you have a histogram like this that shows you the number of times that each sample gave you an average. So it would look something like this. It wouldn't look perfectly like this. But essentially, let's say you take 1,000 samples, and this is satisfaction level 1, this is satisfaction level 3, and this is satisfaction level 5. What you can do by resampling your population over and over and over again is you'll get a histogram like this, which are basically just like blocks. Every time your sample, you do a new sample, you put a new block on. Then you can actually just count and say, okay, 95% of the 1,000 samples that we just took of our population are between here and here. So 95% of the samples that we just took are between, say, 2.5 and 4. So we can say that we are 95% confident that the real sense of belonging for the community is going to lie between 2.5 and 4. And we've come to that number by taking 1,000 samples from the population. Instead of taking 1 sample from the population and making some assumptions about whether the population is really similar or really different from each other, we didn't make that assumption. We just went and took 1,000 samples from the population and found out what the population was actually like. So that is essentially the concept behind bootstrapping. Of course, if you've ever conducted research, this takes us back to the very first problem, which is you don't have time, money, resources, and skills to take 1,000 samples from your community. If you had time to take 1,000 samples from your community, you had time to do a lot of other things. So this is where bootstrapping actually comes into play. With bootstrapping, you take the one sample that you have, this sample here, and you pretend that this sample is your population. That is what bootstrapping is. And what you do is you put all of these people. So we know that this whole average came out to 3. Yeah. So we know the average here is 3, right? This is our actual sample that we took. We had the time, the money, and the capacity to take this sample of 8 people. So instead of repeatedly taking 100 or 1,000 new samples from the population, what we're going to do is we're going to take 100 or 1,000 new samples from this original sample. So instead of throwing the whole population back into the hat, we're only throwing these 8 people back into the hat. And we're going to get repeated smaller samples. So instead of a sampling of 8, we'll take a sample of 4 people. And so we'll get 1 person, 2 persons, 3 persons, 4 persons, this person, this person, this person, and this person. And that'll be our new sample. And we'll take an average of their sense of belongings and say it'll turn out to be 4.2. Then we're going to throw everybody back in the hat again, and we are going to get another sample of 4. So let's say we get this person, this person, this person, and this person. So again, we've thrown everybody back in hats. We got this person again, and we got this person, and we got this person, and we got this person. So take an average of all of their sense of belongings and see what we get. Maybe we'll get 2.5. So this is called bootstrapping, and it's a way to use your sample to resample over and over and over again, hundreds or thousands of times, to see to use the actual population of people to see if they're more or less like each other, rather than just making an assumption about whether your population is more or less like each other. And the reason this works, the reason this was developed in the 70s and became really popular in the 80s and 90s, is because it takes a lot of computing power. Basically, to do this by hand, you can see, would take a very, very long time. But there are all kinds of computer programs. There are online websites that'll do it for free. The, SPSS and R, Stata, they all have things that'll create what's called a bootstrapped confidence interval for you, which is a confidence interval based on the actual distribution in your population, rather than some assumptions about your distribution of your population. So this is why people with certain types of research and certain types of populations really like to use this bootstrap method, because it gives you a sense of how confident you can be about your results without making a whole bunch of kind of theoretical and often hard to justify assumptions about how similar or different everybody in your population is from its others. So it doesn't change the mean. Sometimes people think we're going to throw our small population, our sample size is too small, and so we're going to use a bootstrap and get a more reliable mean. A bootstrap does not get a more reliable mean. This number here, 3, doesn't change. That's the mean. Instead, what all this bootstrapping does is it gets you all of these numbers, which aren't used to change the mean. They're used to create a confidence interval around your mean. Whoops. They're used to create a confidence interval around your mean. So that is what bootstrapping is and why the heck anybody would ever use it. It's actually quite a good tool that does a very useful thing. And so we are very close to the end of the hour. I am going to wait and see. We have a few more minutes. If anybody on the phone or live wants to ask a question, you can just type it into the comments box and we'll answer it. And okay, I missed a question from the qualitative section. So if the person asking the question is still here, I'm going to say it. One more. With the example of an intensity rating on a piece of text, isn't that still qualitative in that the intensity rating is subjective and can't be counted? Absolutely, yes. So in terms of when we take a whole bunch of comments or text data and feed them into some kind of an algorithm that does sentiment analysis on them and decides how intense somebody was feeling, positive or negative, about your new makeup product or your civic hall meeting or your new policy. It absolutely still is qualitative data because it's subjective. So thank you for asking that question, because I think a better way to say it is we have a lot of tools now that allow qualitative data to be used as if it was quantitative. That's what I mean to say. So thank you for asking that question. We have a lot of tools and a lot of methods now that take qualitative data, which is very subjective and very much defined locally and within the context that it's emerging from, and use it like quantitative data, which is, a count of, how many peas are on this pea pod is like objective quantitative data. And because of that, people are making claims of objectivity and certainty about statistical models and statistical algorithms and research that is actually embedded with quite a lot of subjectivity, which is the whole reason that We All Count exists. And so thank you so much for asking that question. That is a very important question. Helped me clarify my own thinking actually about it, which is the point of the Data Salon. Not for me to be the expert and sit up here and tell everybody what they should do or think, but to promote us all learning to demystify, democratize, and demonstrate how to use data together. So the next thing I was supposed to do was show you our website and tell you how to submit your questions for next month. But it looks like our website is having some formatting issues this morning, some back-end website CSS issues. So since that's getting fixed, I will just tell you that you can follow me on Twitter at Datasist, D-A-T-A-S-S-I-S-T. I'm trying to see if I can get to the last slide. Nope. You can email me, Heather, at idatasist.com. And you can find our website at weallcount.com, but don't go there right now because it's broken. If you look on our Twitter, you can find the links to the upcoming data amnesties in the future months, and also the places to submit your questions anonymously if you'd like to ask them by anonymous submission. And if you'd like to email or Twitter them to me, that would be great. So thank you so much for joining us for our first 2020 Data Amnesty Salon. This recording will go up on YouTube, so you can add your thoughts and comments below. Feel free to share it. And most importantly, feel free to submit the other things that you'd like us to talk about, because the point of this is to do things that work for you. Okay, thanks a lot. Bye.